You're going to buy a flying car in your lifetime, not your children, not the generation after them. You and the company that will sell it to you is probably not the one you are thinking of right now. As of March 2025, a Chinese company called EHang became the first eVTOL manufacturer in human history to hold every single regulatory certification required to fly paying passengers commercially. Type certificate, airworthiness certificate, production certificate, air operator certificate, all four. No other company anywhere in the world, not in America, not in Europe, not in Japan, has all four. EHang has them. And right now, today, while you are watching this video, people in Guangzhou and Hefei are buying tickets, boarding a pilotless electric aircraft with no human pilot anywhere on board, and flying through the sky above Chinese cities. The flying car is not coming. It is already here. And by the end of this video, you're going to understand three things that nobody in this story wants to say plainly. First, why China certified a flying vehicle in 31 months when America's best companies are still chasing approval that is now projected to arrive somewhere between 2027 and 2030. Second, the specific vehicle that has already received 7,000 orders globally and begins mass production this year that will make every transportation assumption you currently hold look like it belongs in the last century. Third, the number that tells you exactly how large the prize is that China has decided to win and why every government watching from the outside is only now beginning to understand what losing it actually means. Before we go any further, I need to say something directly. If you're someone who wants to understand where the world is actually going before the moment arrives in the mainstream news, this channel was built for you. Every video we make is built on sourced research and honest analysis, including when the honest answer is uncomfortable. Subscribe right now and turn on the notification bell. The low-altitude economy is going to generate more headlines in the next 3 years than almost any technology story on Earth. And I want you here for every one of them. Here is the moment the story really begins. Not in 2025 when EHang got its final certification, not in 2023 when it got its first type certificate. The moment that matters started with a number that Chinese policymakers said out loud in a government work report, and that number was 5 trillion yuan. That is the projected size of China's low-altitude economy in 2025 alone. By 2035, the projection climbs to 5 trillion yuan, approximately 490 billion US dollars. From a market that barely existed as a defined category 5 years ago. The Chinese government did not put that number in a report to impress investors. They put it there because they had decided this market was going to exist and that China was going to own it. In 2026, China's government work report upgraded the low-altitude economy from a strategic emerging industry to an emerging pillar industry. The same designation language applied to semiconductors and new energy vehicles when the government decided those sectors would define China's economic future. When China makes that designation, it does not mean the industry might grow. It means the state is going to make sure it does. But here's the part that most international coverage of the Chinese eVTOL story gets wrong. It tells you about the government policy. It tells you about the investment numbers. It does not tell you about Wencheng County. Wencheng is a mountainous county in Zhejiang province, 150 kilometers from the nearest major city, with limited road infrastructure and difficult terrain. By every conventional logic of where to test new transportation technology, it is the last place anyone would choose. And in December 2025, China opened the Zhejiangwing eVTOL Center there. Not a research facility, not a demonstration center, but an operational hub where crews maintain aircraft, train operators, and run scheduled commercial flights daily over scenic tourist routes. As of the end of 2026, the plan calls for 297 EHang aircraft flying tourists from that single county, not globally. That county. And those tourists are paying between $100 and $300 US dollars per person for 15 to 30-minute sightseeing flights. Stop for a second and understand what that means. While America's Joby Aviation is still completing power-on testing of its first conforming aircraft, while Europe's regulatory framework requires eVTOL companies to comply simultaneously with both aircraft and automobile standards, while the FAA's most optimistic internal projections for first US eVTOL certification sit somewhere between 2027 and 2028. A mountainous Chinese county that most people outside of Zhejiang province could not find on a map is flying paying passengers on autonomous electric aircraft as part of its regular tourism economy. This is not a gap in ambition. It is not a gap in engineering talent. It is a gap in regulatory philosophy, and it is the most consequential gap in global aviation right now. EHang certified its EH216S in 31 months. 31 months from type certificate application to commercial passenger operations. The FAA classifies eVTOL aircraft as special category aircraft. Joby Aviation, America's most advanced and best funded eVTOL company, backed by Toyota, Delta Airlines, and the United States Air Force, has been working toward FAA certification since 2019. As of late 2025, it entered final stage type inspection authorization, with FAA pilot flight testing projected for 2026 and first certification now expected no earlier than 2027. That is a minimum of 8 years from program initiation to certification. EHang did it in 31 months. The question that deserves an honest answer is whether that speed is a feature or a risk, and the honest answer is that it is both, and ignoring either half makes the story wrong. China's regulatory approach certifies simpler aircraft first, accumulates operational data from real flights with real passengers and real conditions, and uses that data to inform the certification of more complex designs. The EH216S is fully autonomous, no pilot on board, which reduces cockpit complexity dramatically compared to piloted Western designs that must certify both the aircraft systems and the human-machine interface simultaneously. By the time EHang applied for commercial operations, it had completed more than 40,000 test flights across 17 countries. Those were not simulated flights. They were real aircraft in real air, under real conditions, accumulating data at a pace that no certification timeline in the West has matched. In September 2025, 2 autonomous EHang aircraft collided in Shenzhen. The CAAC reviewed the incident. Operations continued. The incident became a data point in the ongoing refinement of China's low-altitude airspace management system, rather than a program-ending event. That response is different from what a similar incident would produce inside the FAA's certification process, where a single failure mode can add years to a timeline. Whether that difference represents appropriate caution or excessive bureaucracy is a genuine debate. What is not a debate is the operational reality it has produced. China has tens of thousands of paying passenger flights behind it. America has none. And here is where the story shifts from regulatory philosophy into the specific vehicle that made 7,000 people around the world decide they wanted to own one before it was even certified for sale. The vehicle is called the Land Aircraft Carrier. The company behind it is XPeng Aero HT, the aviation subsidiary of XPeng Motors, one of China's most sophisticated electric vehicle manufacturers. The name sounds like marketing. The engineering is serious. The Land Aircraft Carrier is a split body system, a ground vehicle that drives on ordinary roads, carrying in its rear section an electric flying module with 6 propellers that deploys, takes off vertically, covers up to 30 kilometers by air, returns, and folds back into the ground vehicle in under 5 minutes. The flying module is autonomous. The driver of the ground vehicle does not need a pilot's license for the current configuration. You drive to a location, deploy the module, it flies while you watch, it returns, it folds back in, and you drive away. Or you fly in it yourself, depending on the certification pathway the company is pursuing for crewed operation. By October 2025, at the Dubai GITEX exhibition, XPeng Aero HT received a single order for 600 units from Middle East buyers, the largest overseas bulk order in the history of the global flying car industry in a single transaction. Cumulative global orders, as of mid-2026, have exceeded 7,000 units. The manufacturing facility in Guangzhou, built specifically for this vehicle, is targeting an annual production capacity of 10,000 units. The company's 2026 budget for XPeng Aero HT alone is 3 billion yuan, approximately 417 million US dollars. XPeng has invested over 10 billion yuan in this program across the past decade. But one vehicle is not the story. The story is what is happening behind it. Because while XPeng is preparing mass production of the land aircraft carrier, Autoflight unveiled the Matrix in February 2026, the world's largest eVTOL aircraft. A 5-ton class electric aircraft with a 20-meter wingspan, 17.1 meters long, capable of carrying 10 passengers or 1,500 kilograms of cargo. It flew its demonstration at Kunshan. It comes in a passenger configuration with business class seating, climate control, and a bathroom, and a logistics configuration that can carry 2 standard AKE air freight containers. This is not a flying car. This is commercial electric aviation designed to replace short-haul regional flights in the same way that electric vehicles replaced short fuel stops. And in Wuhan, in Hubei province, at the Optics Valley Low Altitude Economy Park, a company called EHang Technology flew something that made Euronews describe it as a UFO. Because it looks like one. A saucer-shaped aircraft with its propulsion system hidden entirely inside the body, no visible rotors, taking off vertically from urban spaces, hovering, moving laterally with precision, landing smoothly. The founder called it a true breakthrough in efficiency and design. The hidden ducted fan propulsion system is not a cosmetic choice. It is specifically engineered for flight in confined urban spaces, where exposed rotors create safety risks and noise problems that make dense city operation difficult. 3 companies. 3 completely different vehicle architectures, all in commercial operation or production phase, all in China. All in 2026. This is not coincidence. This is an ecosystem. And this is the moment I want to stop and ask you something directly. You clicked on this video because something in the title caught your attention. Something about flying vehicles surprising people, but the real surprise is not the vehicles themselves. The real surprise is the speed. The real surprise is that while most of the world's population is still thinking about flying cars as something that might happen in the distant future, one country has already built the regulatory framework, the manufacturing capacity, the infrastructure, and the paying customer base to make it real. If that shift matters to you, if understanding where the world is going before it arrives matters to you, subscribe to this channel and share this video with one person who would find this as significant as you do right now. Now, I want to give you the infrastructure number because the vehicles are only half of what makes the low-altitude economy real. The other half is where they take off and land. China has a concept called vertiports, designated takeoff and landing sites for eVTOL aircraft, built into the fabric of existing urban and transport infrastructure. Rooftops of shopping centers, ferry terminals, scenic area entrances, highway rest stops. The government's plan, embedded in the 15th five-year plan running from 2026 to 2030, calls for a national network of vertiport infrastructure that connects the eVTOL network to the ground transportation grid, the same way airports connect to highway systems. 30 provinces in China have already implemented dedicated low-altitude economy policies. The Zhejiang government designated Wencheng as a county-level low-altitude economy pilot and subsidized vertiport construction directly. This is not one local government experimenting. It is a nationwide parallel deployment of vehicles and the infrastructure that makes them usable. Huawei has built an AI-powered air traffic management system running on its Ascend AI chips that can process millions of simultaneous flight paths per second. It has undergone city-scale simulation tests in Shenzhen. The system is designed to manage thousands of autonomous aircraft operating simultaneously in the same low-altitude airspace. The coordination challenge that is the hardest unsolved problem in urban air mobility at scale. Huawei is not solving it in a laboratory. It is solving it at city scale with simulation data that will eventually become operational data. KITL, the world's largest battery manufacturer, is developing high-density battery cells specifically for eVTOL applications. Batteries that must balance energy density, weight, charge speed, and cycle life under the specific demands of repeated vertical takeoff and landing operations. Zhongfu Shenying has cut the production cost of T1100 grade carbon fiber, the material that makes eVTOL airframes light enough to carry passengers at the weights and speeds that make the economics viable. A single XPeng land aircraft carrier uses up to 300 kilograms of carbon fiber in its construction. The supply chain for that material now exists in China at costs that are genuinely commercially viable rather than aerospace grade prices, accessible only to defense contractors. This is what an ecosystem looks like from the outside when it is already functioning. Not one company with the technology. A whole supply chain, battery manufacturers, airframe material suppliers, AI traffic management systems, regulatory frameworks, government-subsidized infrastructure, and multiple competing vehicle manufacturers, all moving at the same time toward the same market. The West's equivalent right now is a collection of individual companies, each pursuing individual certification timelines with individual supply chains and individual regulatory pathways in individual countries, whose aviation authorities have not yet issued a single commercial eVTOL operating certificate. Now here's the steelman that honest coverage requires. The Chinese eVTOL advantage in 2026 is real and significant. It is also not without genuine limitations that the most credible industry analysts are direct about. The EH216S is a two-seat autonomous aircraft with a 30-kilometer range and a flight time of approximately 21 minutes. It is a remarkable achievement for what it is. It is not a replacement for regional air travel. It is not an intercity mobility solution at this configuration. The gap between a tourism sightseeing flight in Wencheng and a genuine urban commuter vehicle that replaces a car journey in a dense megacity is a gap in range, payload, all-weather operating capability, and urban airspace density management that the current operational fleet has not yet fully bridged. Joby Aviation's aircraft, when certified, will carry 4 passengers at 200 miles per hour with a 250-mile range, specifications that make it genuinely useful for the kinds of intercity regional transport that represent the high-value commercial opportunity in urban air mobility. America's approach, slower, more expensive, more regulatory demanding, is producing vehicles with flight envelopes that go significantly further and faster than anything currently certified in China. The question of whether that specification advantage is worth the time it costs is the genuine debate at the center of this industry, and there is no clean answer. What can be said cleanly is this. China has 40,000 commercial passenger flights behind it. America has 0. China has paying customers booking tickets. America has investors writing checks to companies still seeking certification. China has a national vertiport infrastructure plan inside its 5-year plan. America's vertiport planning exists inside individual city pilots and private real estate deals. China has a market worth $201 billion in 2025, and are growing at a compound annual rate that independent analysts put between 30 and 35%. America's first certified eVTOL service does not yet have a launch date. The lead that China built in this industry did not happen because Chinese engineers are smarter than American engineers. It happened because China decided, at the government level, earlier than anyone else, that the low-altitude economy was a real market that was going to exist, and that building the infrastructure, the regulatory framework, and the vehicle manufacturing ecosystem simultaneously was worth doing before anyone could prove the demand was there. That is exactly the approach it used in high-speed rail, solar panels, electric vehicles, and battery manufacturing. The pattern is the same. The market is different. The lead is real. Here is what this story actually means. Not for China, for you. If you live in a city that is currently discussing traffic congestion, you live in a city where the economics of urban air mobility are going to become relevant within this decade. The low-altitude economy is not a niche tourism product. It is an alternative transportation layer for a world whose ground infrastructure was not designed to handle the density of the population it now carries. The companies that define the standards, the safety record, the pricing, the fleet size, and the infrastructure network for that layer in the next 5 years will hold the same kind of structural advantage in urban air mobility that Boeing and Airbus held in commercial aviation for 50 years. China has 40,000 flights of operational proof. It has the only companies in the world with the full suite of commercial certifications. It has a national vertiport strategy, a battery supply chain, an AI traffic management system, a carbon fiber supply chain, and a domestic market worth hundreds of billions of dollars. It has vehicles ranging from 2-seat autonomous sightseeing aircraft to 10-seat commercial eVTOL transports to a UFO-shaped urban aircraft to a car that unfolds into a flying machine and receives 7,000 global orders before mass production begins. The flying car is not coming. It came. You just did not hear about it yet because it landed in Guangzhou. If you stayed through this entire video, I want to thank you for something specific. You just watched a story about the future of transportation with the same seriousness it deserves, not as science fiction and not as hype, but as a documented industrial and regulatory development that is already producing commercial revenue in a country that is very deliberately doing this first. So here's the question I want you to answer in the comments below. One answer. Your most considered thinking. Given that China now has 40,000 commercial eVTOL passenger flights behind it, and no Western country has any, do you believe the FAA and ESA should accelerate their certification timelines and accept higher near-term risk to close the gap? Or is the slower Western regulatory approach the right one, even if it means years of commercial disadvantage? One position. 2 sentences of reasoning. Let us build the most substantive debate about urban air mobility regulation that any YouTube comment section has ever hosted. Subscribe to this channel, turn on the notification bell, and share this video with one person who needs to know that the flying car story has already started. I will see you in the next one.